Okay, so this is the first video on the topic of momentum and force. So first we look at acceleration in 2D motion. Now acceleration we find that acceleration is rate of change in velocity with respect to time. Or in layman's words, we say how much the velocity is changing in 1 second. So when we considered motion in a single line, motion in 1D, it was pretty straightforward. So let's just look at this simple example of 1D motion. That my particle is that my motion is happening along this in this direction, and initial velocity is suppose 10 meter per second, and final velocity is 20 meter per second, and the time it took was 2 seconds. Then we can find how much the velocity changed in 1 second. Here we find that velocity changed by 10 meter per second in 2 seconds. So in 1 second it changed by 5 meter per second. Or we could straight away use the equation as well, which was v equals to v minus a equals to v minus u divided by t. Okay, basically let me start with the equation which you might be familiar with. So this is the first equation of motion that we normally use. If we rearrange this equation, we get a is equals to v minus u divided by t. So putting these values here, we get 20 minus 10 divided by 2, which is equals to 5 meter per second. And it's a simple one in which initial and final velocity both are in the same direction. But if I have a case like this, when u equals to 10 meter per second, v is equals to minus 20 meter per second, and t equals to 2 seconds, then what do? We do the same thing again here. So v is equals to, sorry, I'll try to use this a acceleration equation straight away. So a is equals to v minus u divided by 2, and that gives me minus 15 meter per second square. Sorry, that was square 2. What it means is the negative sign here means that acceleration is in the negative direction. So I mean my initial velocity is positive, so that is my positive direction, and my acceleration is in a direction opposite to that initial velocity. Right now, this, because we are taking sign here, it clearly means that we are dealing with vectors. So far these kind of cases in which the motion is along a single line, along one line in one dimension, then these kind of calculations are okay and they suffice. They are sufficient for us. What happens if we consider 2D motion in which initial and final velocities are in different directions? So let's take a case here. I'll basically go straight to a numerical example here. So say my initial velocity is equals to 12 meter per second, and the direction is east. Just keep in mind that velocity is a vector, so I have to give the direction as well. So this is my due east, and here, because I mentioned the direction, I can state that this is a vector. And say my final velocity is also 12 meter per second, but it is in a direction due north, and the time that it took is 4 seconds. And now I need to find the acceleration. Now, because the vectors are given, I need to say that I need to find the vector acceleration here. The equation that we have used so far, that was v minus u divided by t, we can write that as a vector equation to imply that here we are dealing with vectors, and we write it like this. Another way it can be written is a is equals to delta v divided by t. Delta v is nothing but the change in velocity, but again that delta v also is a vector. So this question, all the first step we need to do is to find the change in velocity. All right, so let me write this equation like this, that change in velocity is equals to delta v is equals to v minus u And I can rewrite that as v plus minus u. They both mean exactly the same thing. What this means here is, what we are doing here is we are adding v with this vector minus u. And how do you find a minus u? If you want to find a minus of a negative of a vector, you need to just change the direction. You just need to reverse the direction. So that gives us a way to find the delta v. How we do it? We first draw the velocity, both our vectors. So my u vector is, it's 12 meter per second due east. So I will say that is my u vector. And now I will draw minus u. And minus u is just the same vector but in opposite direction. So length is still 12, but the direction has reversed. And v is my vector which is due north. So that is my v, and that is 12 too. So to find delta v here, I need to add vector number 2 here and vector number 3. Vector number 3 is this and vector number 2 is that. So I just need to add these two vectors, and addition we are familiar. So we'll just simply to add these two vectors, vector number 2 and vector number 3, I just need to draw them, and then I need to draw the final vector, resultant vector. So I will draw the horizontal one first. This is my 12, this is my minus u starting from here, and then I draw my vertical one. That is, let me do it, it's getting congested here, so let me scroll a bit down there. So I need to, again, just to repeat, I am adding vector 2 and vector 3, and that will give me delta v. So let me draw. This is my vector number 2, which is length is 12, and this is minus u, and again drawn in the wrong place because I need to go up, so let me draw it here. Third time lucky. So this is 12 minus u, this is my vector minus u, vector 2, and the vector number 3 is v, 12, the length is 12 and it is vertically up, basically it's in the north direction. So that is 12 and that is v, and this vector from the starting point that is my delta v. Alright, so once we get into this form, it's all we are doing is just adding the two vectors. So using Pythagoras theorem, we can find the magnitude of delta v is equals to square root of 12 square plus 12 square, which gives me 16.97 meter per second, and I need to find this direction as well. So that direction I will call it theta. Whenever you're finding a vector, if the data allows you, you should find the direction as well. So this theta here is equals to tan inverse 12 over 12, which is equals to 45 degree. So now I can write my delta v properly. I can say that delta v with an arrow indicating that this vector I'm talking about, delta v is equals to here I was talking about just the length of the delta v. So delta v is equals to 16.97 meter per second. Now you have to be careful about the direction that we got here. This direction 45 is from the west here towards the north. So west 45 degree towards north. So that's my delta v. And now because my time for this change in velocity delta v, the time it took was 4 seconds here. So I can just find a is equals to delta v over t, which is equal to 16.97 meter per second divided by 4. And because you are dividing a vector by, to find the acceleration, you are dividing this vector delta v by 4 by a scalar quantity. So the direction of a will be same. So this gives you 4.243 meter per second square. And because in this equation, we look at in this equation, A is a vector and delta V is a vector and T is a scalar, it means A will have the same direction as delta V. So we need to write the direction here as well, west 45° north. So the takeaway from this video is that when you want to find difference of two vectors, you need to reverse the second vector like here, and then you need to add to the first vector. That is the biggest takeaway from this video.